to the problem on animation osmosis from Chapter 7. It will benefit you greatly to read this paragraph that's above the problem. Okay, but basically the gist of it is saying that the greater the number of the solute particles that would dissolve in water, because that is going to be our solvent in this problem, that the greater the osmotic pressure. So the more solute particles that can dissolve, the greater the osmotic pressure. Okay, and so we're supposed to rank these compounds below. Okay, and so it goes back to really remembering our ionic compounds and our covalent compounds. But our ionic compounds completely dissociate in water. Okay, so the first two compounds given are ionic. Okay, and we have calcium chloride and we have potassium chloride. Okay, but the calcium chloride, we have 1 molar of both of these. But calcium chloride is going to completely dissociate because our ionic compounds completely dissociate in water. It's going to form 1 calcium ion and 2 chlorides. So technically it's going to form 3 particles in solution. Okay, so 3 ions. So we're going to rank it as the highest. Okay, and our KCl is going to form 1 potassium ion and 1 chloride. Okay, so it only forms 2. We're going to put it next. Okay, then we have our 2 covalent compounds. Okay, these are not ionic, these are actually polar covalent compounds, but we have 2 molar. So we can technically say that we're going to form 2 methanol. Okay, this compound here, CH3OH, is methanol. It doesn't dissociate. Okay, it doesn't dissociate into ions, but because we have 2 molar, it's going to produce 2 solutes, or you're going to have 2 solutes in solution. Okay, and then here we can rank this as going to be the lowest because it is a covalent compound. It doesn't dissociate, and we only have 1. So technically, if you just have this one of your this glucose molecule, then it's going to just dissociate into, or doesn't dissociate. So you're just going to have 1 solute in solution. Okay, and so these overlap, and so if we look at this in detail, so ionic compounds completely dissociate, and we have 2 chlorides, so total we have 3 solutes, or 3 ions, and then we have 2 methanol because it doesn't dissociate, and we have K+. Okay, so our potassium chloride dissociates completely, but we just have 2 particles present, just like we do with our 2 molar of methanol. And then for our C6H12O6, we just have 1 6 because it does not dissociate. Okay, and so the more the number of particles, the greater the number of solute particles dissolved, the greater the pressure. So that's why we rank these in this order. I hope this helps.